Okay, in example number 3, we're going to be restricting the domain. If a function is not one-to-one, it cannot have an inverse. If we restrict the domain of the function so that it becomes a one-to-one, thus creating a new function, then this new function will have an inverse. So how do we go about that? Given a polynomial function, restrict the domain of a function that is not one-to-one and then find the inverse. Number 1, first, we have to restrict the domain by determining a domain on which the original function is one-to-one. Step 2, we're going to replace f of x with y. Step 3, we're going to interchange x and y. Step 4, solve for y, and then rename the function or pair of functions f inverse of x. Step 5, revise the formula for x inverse of x by ensuring that the outputs of the inverse function correspond to the restricted domain of the original function. So for example number 3, we want to be able to find the inverse function of f. And that function of f is going to be in 2 parts. But the original function of f of x is equal to x minus 4 squared is not a one-to-one function. So if you look over here to the far right, okay, this is the graph of f of x, which is equal to x minus 4 squared. So what we're going to do is, if you take a look at the function right now, it doesn't pass the horizontal line test, which means currently it's not a function. So we have to restrict the domain. So here, if we look at this side, okay, and cut the other part in half, well, this side would represent all the values where x is greater than or equal to 4, because that's where it's starting at 4. Now, if we look at the left side, and again, that means that we're looking at this function, okay? Now, if we want to look at the left side of this parabola, okay, that means that we'd have to restrict everything on the right side and delete everything on the right side. But that means that all the x values have to be less than or equal to 4. So that's going to represent graph B. So you can see here in the next step, they've replaced these graphs knowing that there's only one piece where x is greater than or equal to 4, and the other one is where x is less than or equal to 4. Now we're just going to find the inverse of that function, of the original function x minus 4 squared. So we're going to replace f of x with y, so y is going to equal x minus 4 squared. Then we're going to interchange x and y. So there's our first step. Our second step now is to interchange x and y. And then we're going to have to take the square root of both sides. And what I want you to notice in step 3, that this becomes plus or minus the square root of x, which is equal to y minus 4. And if we add 4 to both sides, that means y is going to equal 4 plus or minus the square root of x. Now, we found the inverse of this function, but this is not a function as written because that means there are 2 solutions. So we need to examine the restrictions on the domain of the original function to determine the inverse. Since we reversed the roles of x and y for the original function, we looked at the domain, the values x could assume. When we reversed the roles of x and y, this gave us the values y could assume. So for this function, x has to be greater than or equal to 4. So for the inverse, we should have y is greater than or equal to 4, which is what our inverse function gives. So for part A, the function f of x, which is equal to x minus 4 squared, where we have the restriction of x is greater than or equal to 4, then we're looking at this restriction. So that means that has to be a positive value. So the domain of the original function was restricted to x is greater than or equal to 4, so the outputs of the inverse need to be the same. So that means we're looking at the plus or the positive case, and that's why the f inverse of that restriction is going to be 4 plus the square root of x. Now, if we take a look at the next one, f of x, which is equal to x minus 4 squared, the restriction says that x has to be less than or equal to 4. The domain of the original function was restricted to x is less than or equal to 4, so the outputs of the inverse need to be the same. F of x is less than or equal to 4. And we must use the negative case, and that's why f inverse of x is equal to 4 minus the square root of x. Now, on the graphs in figure 6, we see the original function graphed on the same set of axes as its inverse function. Notice that together the graphs show symmetry about the line y equals x. The coordinate pair 4, 0 is on the graph of the function, and the coordinate pair 0, 4 is on the graph of the inverse function. For any coordinate pair, if a and b is on the graph of f, then reversing those values to make it BA is on the graph of f inverse. Finally, observe that the graph of f intersects the graph of f inverse on the line y equals x. Points of intersections for the graphs of f and f inverse will always lie on the line y equals x.